Additive manufacturing is technology turning manufacturing on its head. It's a smarter, faster way to produce, perfect for a small, ultra-efficient Singapore. Additive manufacturing in Singapore is spearheading industries like biomedical, design and building construction, precision engineering, electronics, aerospace and marine offshore, as well as clean technology.
What we're working on is developing new materials, new ways of printing, and designing these materials to suit your body part, and then training the doctors to put them back into your body.
AM can be used to make injection molds with conformal cooling channels, as well as low-volume customized jigs and fixtures.
We have already seen door brackets which has been 3D printed and have been used in the aeroplanes. We will also see fuel nozzles that will be used in the aircraft engines.
So an exciting development is development of hybrid technologies. This is a combination of both additive and subtractive-based technologies, such as milling. Solar panel and wind turbine are some of the emerging applications with AM in the clean technology sector. The water membrane is another very exciting area that's coming through. Additive manufacturing is a huge area of growth for the future, along with robotics and automation. In Budget 2016, the government announced the Industry Transformation Program. Additive manufacturing, automation, sensors, analytics, these will be the enablers.
AM is identified as a disruptive technology. It has the power to impact lives, businesses, and global economy. It is a game changer. The current market size is about 7 billion, and we should see this number triple by the year 2020 to 21 billion.
The AM ecosystem, as we see it, is made out of three main parts. Universities that are training students for working in the 3D industries and do research in corporations that do prototyping work, actual parts, and scale-down model to train people, and individuals that take advantage of the fact that 3D can do small quantity productions.
It's critical selecting the right applications that are technically feasible and economically viable, then having a workforce that is able to collaborate and innovate to create the new applications and solve the challenges.
We want to help companies translate their technologies into viable commercial solutions. We do this by partnerships, seeding capabilities, and skills training to position them well into the next industrial revolution. If you are interested to know more about AM and the new wave that's coming, come talk to us today.
Mobility goes additive.
We've started our activities in additive manufacturing in October 2015, and that time we decided to focus on the reproduction of missing spare parts. And that was also quite the time when we contacted Big Rep.
In our cooperation with the Deutsche Bahn, we are focusing on producing a spare part in form of a headrest for the first time 3D printed by Big Rep.
What we sometimes need are spare parts which come from very old trains.
Instead of investing a huge amount of money in huge warehouses, we are now able to 3D print spare parts on demand.
We need very special materials which have to be flame retardant, and our levels concerning flame retardancy are very high.
So together with our material specialists, we are focusing on creating a new material that enables both rigidity and flame retardantness in one go.
In order to assure its neutrality, Deutsche Bahn has joined equal founding members for Mobility Goes Additive and has aligned the network based on their needs.
3D-Druck und die Deutsche Bahn. Und was druckt ihr dann so alles?
Eine große Bandbreite von Kunststoff bis hin zu Metall. Welche kann ich dir hier zum Beispiel mal zeigen? Schau mal, hier ein Lüftungsgitter.
Okay. das ist jetzt aber aus Kunststoff, Plastik.
Wir haben aber in der Zwischenzeit auch schon Metall gedruckt und das zeige ich dir jetzt mal unterm Zug.
Auch super.
Hier ist der Klemmenkasten, den ich dir zeigen wollte. Der ist aus Aluminium und den wollen wir jetzt nachdrucken.
Okay, und wie wird dann sowas ausgetauscht und gedruckt?
Der wird ausgebaut, wird mit einem Handscanner vermessen, wird nochmal nachbearbeitet und als Datenfile an den Druckdienstleister geschickt. Und wie das da genau funktioniert, das wird dir Florens gleich zeigen.
Hier beim 3D-Druckdienstleister wurden die Daten aufbereitet. Es wurden Stützstrukturen erzeugt, um das Bauteil abzustützen und an dieser Grundplatte anzubinden.
Damit man es so hochbauen kann.
Richtig, ja.
Das ist also where the magic happens.
Genau, 3D-Druck oder wie es in der Fachsprache heißt, additive Fertigung, basiert im Prinzip auf dem schichtweisen Aufbau des Teils.
Ja.
Bringen eine ganz dünne Schicht Pulver auf, die wird mit dem Laserstrahl aufgeschmolzen, dann senkt sich diese Grundplatte ab, beschichte wieder, schmelze auf und das Ganze wiederholt sich, bis mein Teil gefertigt hat.
Da ist er, unser fertiger Klemmenkasten, der, wie ich finde, ganz ordentlich aussieht.
Ja, ist sehr gut geworden.
Mobility goes additive. You're welcome to join us.
I'm happy to sign an MOU with NAMIC today. We consider NAMIC as the 3D printing network not only in Singapore but also in the Asian market. And this is what our 99 members are longing for. And just last week we initiated the next network, which is called Medical Goes Additive. So with 2 networks we want to enhance the possibilities of additive manufacturing throughout the world.
Om onze reizigers een goede, comfortabele treinreis te kunnen bieden, schaft NS nieuwe treinen aan en moderniseert bestaande treinen. De eerste generatie Intercity dubbeldekkers, de Firm, rijdt alweer 20 jaar rond. De monteurs van NetTrain in Haarlem gaan alle Firm-treinstellen volledig moderniseren. Aan zo'n grote operatie gaat een intensieve periode van ontwerpen vooraf. Daarbij wordt nauw samengewerkt met leveranciers en de afdeling die de ombouw uitvoert. We bouwen daarbij voort op de inzichten van een succesvolle eerdere modernisering van dubbeldekkers. Voordat NetTrain de Firm-treinstellen in serie gaat ombouwen, starten we eerst met de ombouw van 1 trein, om die te testen in de praktijk. Engineers, kwaliteitsmensen en veiligheidsmensen werken samen met monteurs om het ontwerp en de ombouw tot in de kleinste details in de vingers te krijgen. Daarna kunnen we alle andere 412 rijtuigen onder handen nemen in serieproductie, net als in de auto-industrie. Er is speciale outillage ontwikkeld die de inbouw zo snel en veilig mogelijk laten verlopen. De monteurs vernieuwen de ramen, het interieur en de toiletten volledig. Een deel van de Firm wordt hergebruikt, zoals het balkon. Door de modernisering wordt de trein ook weer zuiniger en duurzamer. Bijvoorbeeld door verlichting die zich aanpast aan de hoeveelheid daglicht. Het bovengedeelte van de geheel vernieuwde trein leent zich door de inrichting wat meer voor rustig lezen of werken. Hier bevinden zich dan ook de stiltezones. Het benedengedeelte kent meer banken tegenover elkaar, loungebanken en extra bagageruimte. Kunst in de trein complementeert het geheel voor de reiziger.
Knorr Bremse is the world-leading manufacturer of proven braking technologies. Over the years, the company's highly integrated systems for the intelligent control and regulation of dynamic braking forces have been installed in thousands of trains. With the system competence and global know-how of Knorr Bremse, Friction Technologies provide the most comprehensive, individual, and suitable offer of friction products for all terrain applications. With one of the world's broadest portfolios, Knorr Bremse assures high-quality products for every application. Our facilities are equipped with the latest production technology to ensure high-quality, reliable, and highly available products. A continuous investment in increasing capacities are Knorr Bremse's promise to the customer for uncompromising availability of spare parts. In-house production and supply chain excellence are key benefits for customers. Knorr Bremse has the capability to provide customers with an individual selection of brake discs and brake pads that significantly influence life cycle costs. This guarantees high flexibility for customer requirements and a short lead time. Hundreds of service-proven friction pairing variations allow us to offer the most suitable solution for each and every customer. Our state-of-the-art testing and analysis facilities allow measurement of friction coefficient, temperature, wear, and noise. Testing is done under extreme climatic conditions and speeds of up to 520 kilometers per hour. This testing excellence allows Knorr Bremse to close up the cycle for every customer application, with the assurance that the most reliable, most cost-efficient, and sustainable system has been designed. Our qualified sales specialists and the worldwide service team strive for a long-lasting partnership with our customers, no matter the application.
very good afternoon, Singapore, and a very good morning, Europe. For all of you joining us from all around the world, this webinar on additive manufacturing, advancement in the land transport industry, coming to you live here from Singapore. We thank you for joining us today, and we have put together a stellar lineup of speakers from Germany and from the Netherlands through our partner network, Mobility Goes Additive, MGA, based in Berlin, Germany. Today, we have the pleasure of gaining insights from leading innovators from the land transport sector who are making significant impacts in this sector and paving the way forward for 3D printing adoption in land transport. We hope to inform you, challenge the status quo in manufacturing, bringing new perspectives to manufacturing, and most of all, to get you on board this journey of creating a better transport system for all of us, and all of that by embracing 3D printing and AM technologies. Without further ado, it's now my pleasure to invite Dr. Ho Chaw Sing, the Managing Director of the National Additive Manufacturing Innovation Cluster, NAMIC, to kick off today's proceedings with his welcome address. Dr. Ho, please.
Thank you, Mandarin. Very good morning and good afternoon, everyone. And those who are listening, probably in the wee hours in the morning, if you're from the United States. Welcome to the NAMIC webinar on the advancement of additive manufacturing in the land transport industry. Thank you all for making time on a Friday afternoon. I know it's a TGIF, so I promise you that whoever is locked in, we have a very exciting lineup in place. We're very privileged and pleased to have with us today our strategic partner and industry experts from Mobility Goes Additive, Deutsche Bahn, Dutch Railways, and Knorr Bremse to share with us their experience on the land transport use cases with AM technology. Now, before I hand this over to our speakers, I thought I would just spend a minute framing the current world context. First, the world ahead of us is challenging, where geopolitical tensions coupled with changes to deep set habits caused by the pandemic will inevitably cause changes to the way we make, consume, recycle, and upcycle. All of us will need to constantly reinvent and evolve to stay relevant and in business. Secondly, businesses, whether it is in the transport sector, education, supply chains, and our deep tech, would be increasingly more interlinked and connected through the adoption of new technologies. And this is something that will continue to gain momentum. And 3D printing has played a very important role in enabling some of these new paradigms in the rapid supplies development and deployment with on-demand high-volume manufacturing. I want to take this opportunity to thank the team who has worked tirelessly behind the scenes to bring this event to all of you. And special thanks again to Mobility Goes Additive and their partners. With that, and without further ado, let me extend a very warm welcome to all of you once again, and let me hand this over back to Mandarin. Over to you, Mandarin.
Thank you, Dr. Ho. Thank you so much for that kind introduction to the speakers, and also a big thanks to our partner network, Mobility Goes Additive. And later you'll be hearing from the man himself, Arvid, Eirich. But first of all, let's go on to our first speaker, who is really all prepared to take us through what he went through in his journey. And he is Florens Lichte from Deutsche Bahn. And he has been managing the implementation of additive manufacturing into operations at Deutsche Bahn. Florens obtained his Master of Science in Industrial Engineering. He joined the maintenance division for railway vehicles, Deutsche Bahn Fahrzeuginstandhaltung GmbH, in 2014. After exploring the first application fields of AM in maintenance as a production engineer, Florens had been leading the AM project team across the group for over 5 years now. With more than 6 years in metal working and construction experience, he still has a strong affection for traditional manufacturing. Here's to take us through on an approach to AM MRO by an European railway operator is Mr. Florian Lichte. Florian?
Thank you, Mahendran, for the kind introduction. Thanks for having me here. It's a pleasure to share with you today some insights on additive manufacturing at Deutsche Bahn. But first of all, what's the scope of AM at Deutsche Bahn? So with our different business units in passenger transport and freight transport and logistics, but also in the infrastructure, we have really a wide range of application. Our main focus are spare parts, because we want to increase the availability of our assets but we are also developing manufacturing tools for our own maintenance processes. We have over 100 different maintenance sites all over Germany. And of course, we are also printing prototypes for new components that need to be tested, like in the image you see on the screen. What's our mission? As I said before, we want to increase availability. So we're talking about parts that are no longer available from the market, that are not used anymore by the original equipment manufacturer, or we're talking about parts that are really hard to procure, where we have long lead times. And in many cases, it's also a measure of a cost reduction. We want to reduce the cost for small lot sizes. As you might imagine, in an industry like ours, it's also very important to establish standards, especially when we're talking about a new innovative technology. So, of course, we also want to drive the establishment of standards within our industry. So we are pushing certification together with other partners like TÜV Süd, and we're also working at or on standardization committees. For us, it's also very important to consolidate the needs within the railway industry. So we are working closely together with the European railways to share our knowledge, but also to address several market needs to the industry. And as a green company, or with Deutsche Bahn claim to be a green company, it's also for us an important technology to reduce material waste, and of course we can optimize logistic processes by using additive manufacturing. So what's our approach? That picture you see in the back was taken end of last year. We've been awarded as a global corporate project of the year last year. So this was a great success. Basically, our key approach is a holistic approach to serve all the business units within Deutsche Bahn. So we set up a competence center basically to develop AM solutions for the different business units. So develop solutions that make sense from an economical point of view, that are technical feasible, and that are also feasible from a legal point of view. One thing when you start with additive manufacturing is, of course, how do you identify suitable parts? I mean, that is key for implementation of additive manufacturing. And when we started back in 2015, we started, I guess, like many other corporates as well, with a top-down approach. We started to look into our ERP systems, so define some criteria, analyze these parts, and test them for feasibility. But this didn't really work out for us because we didn't have sufficient data in our system. So we switched to a bottom-up approach. Over the last few years, we did over 100 workshops, trainings with our colleagues in the maintenance, on the maintenance sides, but also other DB sides. We showed them what the technology can do, how the technology is working, what other industries are doing, what is best practice, what we've done so far. And then we got some thinking, and we worked with specific needs, with their problem parts, testing them for feasibility, printing first for prototypes, and then qualifying the application. And this worked very well over the last few years. So right now we're getting 5 to 10 new ideas every week, so that's quite good. And last year we started with a tool to interact with our colleagues, so they can submit their idea, their need throughout the steel tool. They ask to fill in some basic data on the part so that we know what we're dealing with. They can upload a photo, they can upload technical documentation, and then there's a first evaluation of the part by the system, if it's technical feasible, and if it makes sense from an economical point of view. Currently, we are also using this tool within our second employee competition. This year, it's an international DB-wide employee competition, and our colleagues are asked to submit their ideas in 4 different categories. So we're talking about new parts, parts that need to be optimized, parts that are copied one-to-one, and we have a 4th categories to submit other ideas that don't fit in the other 3 categories. And so far, we've been very successful. We've collected over 100 ideas. I think currently 120 ideas, and this will go on till the end of September, and then we will choose the winners. As you see, we try really to spread the knowledge about 3D printing across the country, across the whole company, so that we get the knowledge to our people. And another means is, of course, training. So in the last years, we also developed several training programs. So starting with a basic training, then training for more advanced guys. Then we have a dedicated program for our colleagues coming from the apprenticeship. So last year we also started installing desktop printers in our heavy maintenance sites, so that every apprentice can print some parts and throughout his time, throughout the apprenticeship. And of course, we also have tailored workshops for specific groups within DB. But let's look into the applications, what we've done so far. I have some examples that we implemented in the last years. So one of our biggest AM applications are these handrail signs. You find them at every station, and basically they indicate the way for visually impaired passengers. And they totally make sense from an additive manufacturing perspective, because there are not 2 plates that look the same, because every station has their own platform arrangement. Then you have street names, like in the case here, the upper plate on this plate. So every sign is different, and that makes it ideal for additive manufacturing. We've printed over thousands of these plates so far, and it saves us a lot of money. As I said in the beginning, one of the main drivers is increasing availability for our asset. Here's an example of a small plastic part. It's a door socket profile that was missing during the redesign process of this suburban train. And the issue was that the original supplier wasn't able to deliver this part in a timely manner, and we would have had to stop the production because we were missing this part. And we were able, with additive manufacturing, to supply 240 parts within 10 working days without any production stop. So this was a huge mistake. This was a huge success. But there are also some smaller parts, like this tool that is used by the electricians working on the electric system of the vehicle. It's part of their personal protective equipment. So basically you put it on the circuit breaker, and it locks the switch. So when they are working on the electrical system, it prevents them from anybody touching the switch. And as you see on the left picture, formerly this part was made of almost 10 different components, and by using additive manufacturing or design for additive, we were able to produce this as one part. This example we have over here is one of our heavy metal use cases. Beginning of last year, we had an issue with two of these parts called secondary volt stops. They are bolted underneath the car body of a high-speed train. And in fact, they limit the lateral movement of the car body relative to the bogie. And this issue resulted from an accident repair. So we had to fix an accident repair on a vehicle. And this is a part that we normally don't have on stock. So this part isn't meant to be replaced during the regular maintenance schedule. We don't have it on stock. And the option was we got a quote from the original equipment supplier offering 4 parts minimum order quantity. But we would have waited 10 months to get the parts, and we would have to pay some serious amount for the initial tooling. So this wasn't an option for us, and we thought, why can't we print this part? And we took a deeper look on the wire arc additive manufacturing technology. We printed a part by this technology before, so we had some experience with the technology. And as you see on the pictures on the left side, this is how it looks. You have the CAD model, and then the near net shape part that was built layer by layer. You see the test specimen on the left side of the part. So you get the mechanical properties, and that you can issue a certificate of conformity. And below, of course, the machine part. And this is a part that is really safety relevant. So we needed to make sure that it meets all the requirements. So as you see on the right side, we did a test with this part with the loading that the part is under the installation. And we were able to simulate 30 years of operation with this test. And finally, the part was good to go into field testing. But we are not only, as I mentioned before, we are not only talking about end-use parts. We are also looking into the tooling sector. This is a good example of a quite a simple template that helps the worker to apply stickers, for example, in this case, on a headrest. So you have this pictogram with a seat number that needs to be applied to the headrest, and this template helps them to accurately stick this pictogram to the headrest. We have other good examples, for example, sticking pictograms in the interior of the vehicle, and this saves a lot of time. So this was really good process optimization. But we're also not only considering printing polymers or steel parts. We are also looking into printing concrete. This is a good example of from the Netherlands, a printed staircase. That's also something we're currently looking at and that we will evaluate in the future. So I hope I could give you a good impression what we are doing so far, what challenges we are facing, and yeah, I'm looking forward to your questions later on.
Right, thank you so much, Florens. I'm actually looking forward not only to the questions, but also to the winners from your Deutsche Bahn competition that you've been running. Yeah, the last year when I was in Germany, we heard about it, and I think you and one of the winners you shared previously was really good. And so this year's list of winners and the competition entries will be very interesting to look forward to end of September. Yeah, thank you. And our next speaker is Joris van der Zante. He has an MA in economics. He's born in 1975 and he's not so shy about his age. Very youthful looking presenter. And after several years of working as a strategic buyer at NS, which is the Dutch Railways, Joris started to explore the opportunities of 3D printing in 2017 to solve problems posed by obsolete parts. He has built a broad network around 3D printing with current rail suppliers, knowledge centers, and additive manufacturing startups. He's proud of the position of NS the Dutch Railways regarding its sustainability approach and wants to contribute to this by speeding up additive manufacturing in the supply chain. This year, he joined the MGA Railability Working Group, and to tell us more about advancement of an AM approach with user cases and challenges, here is Joris, right from Netherlands. Joris?
Thank you very much for your introduction. Let's start. Yeah, I hope you see my screen.
Yes, we do. Thank you.
Okay. Dutch Railways. I saw the video at the beginning, but it was all in Dutch. So maybe quickly introduce the Dutch Railways with this funny slide. As already told in the introduction, NS really focused on sustainability. Already in 2017, 100% of our trains are running on green energy and the windmills. We, together with our supplier of energy supplier, we built a plant, windmill plant, which provided enough energy for the whole Netherlands, for NS in total. I think this is, I think NS is one of the few who's totally running on green energy. And besides that, we are a green country because we use a lot of bikes. So from getting from the train to your location, you can use bikes. We have a lot of bikes standing at the stations, which can be rented by our passengers. And this is in a nutshell, I think, the mission of NS to have a green, sustainable mobility approach. I think this is also a link to use additive manufacturing, because that's a green production as well, because you don't use that money. Yeah, there's not that much waste in production. Also, I will tell you later on, it's not focusing on really on printing on demand. So you don't use that money stuck at our place or at the supplier, and that will and less transport. So all kinds of benefits which also benefit a sustainable approach. So we started. I think a little bit later than Deutsche Bahn. I think the big brother who are really watching, and we have a lot of contact with Deutsche Bahn. So I think some parts are copied from Deutsche Bahn, more or less the same. But I will tell you just the approach we have. We are a lot smaller, of course, so we have a small team. But we started in 2017 with a pilot of 10 parts. Also to convince our management, okay, is there really benefit in 3D printing? And what we see that the benefit was really on the supply chain. So our the 3D printing additive manufacturing is really driven by supply chain. I'm as well working on supply chain. I think that's maybe different than from Deutsche Bahn, because that's more from a technical department driven. So what we saw, of course, in obsolescence, there's a huge advantage, because when you only need one item which is not obsolete anymore, 3D printing can is a really nice way, less cost to produce the product again. And from that on, we see that there's the business case is not only in obsolescence, but already in the long tail. A little bit get back. This is the phases of the lifetime of a train. You have the starting phase, the guarantee phase, and the phase out. 30 years or maybe sometime longer is a train running, and especially on the phase out and already before we get problems with availability of spare parts. We see that on high MOQs. Minimum order quantities are getting up. Lead times get longer, and sometimes suppliers don't produce it anymore, and that's and then therefore I think there's the business case of additive manufacturing that plays. Now I think Deutsche Bahn has a kind of similar picture. This is from 2019. We have more than 100 different items printed or they're indirectly printed using molds which are printed. And I think we are now facing 150, around 150 parts. Because of COVID, it's a little bit, we cannot speed up because we cannot get together and look for new parts. So I think, but still our approach is that we have 3 pillars. That's building AM knowledge. So we did some trainings, etc. I will tell you later on. We have partner engagement with our suppliers. We have also been in contact with Knorr, Bremse, Alstom, CAF, some other small suppliers, and to get them on board, because we don't want to be a production company. We don't have any printers. We have everything outside. So that's our approach, to get the partners on board. And then where we are focusing on, and I think that's that we are creating an AM control center, I call it. It's a data center to get looking at data and get the parts selected which can be a benefit for NS. I will tell you later on. Okay, now learning by doing. So we want to build some knowledge, because we want to have a good discussion with our suppliers about what's possible and not. We set out yearly goals for printed parts, so we get moving, and we print sometimes parts we are not benefit, but we learn from, okay, what's possible, what's not possible, and we are now focusing more on really printing parts which are benefits. So we have printed metal, we print plastics. And sometimes said, okay, we should not do printing simple metal parts, because that's too expensive. They should have be very complex, and then printing is useful for metal. So most of the parts we printed were plastics. Internally, we did a lot of communication to get people, get ideas. We did some challenges. For instance, for printing with reused plastics, we invited startups to think about a platform for staircase. I don't have a picture here, but therefore looking if we can reuse materials. Now, for instance, from the train and getting printed items, and to get ideas from there. Then we also did a questionnaire with our suppliers to get suppliers on board, and then maybe there were some suppliers which are already up front with additive manufacturing, and they could help us with our goals. Now Alstom is one of them, and we asked Alstom also to train our people together with people from Alstom to get a really a team working on this area of 3D printing. This picture is the first obsolete item we printed. It was back in 2017. This example, it was not available anymore, and we had to change this to a low volume item, because it was more than 100 grams, and we have to change the inside, that it was so it could be compliant to the flame retardant standards. Now this is how I see we built our ecosystem. On one side we have the new world, the 3D world with printing hubs, and on the left side we have the real companies. And we have the knowledge centers, and we have 2 companies which help us a lot. Dimenex, that's our one-stop shop for 3D printing. It's a platform where they have contracted several print hubs, so we could focus only to one partner, and they will select the printing companies together with our quality department. So we have one printing hub in the Netherlands, Oceans, and we have FIT in Germany, FKM in Germany, and we have Materialize in Belgium. And then we have the company Castlab. It's a casting company, and they want to change the whole concept. They really want to focus as well on 3D printing, not using casting anymore, but they want to print the molds and then at the end normal production of casting components. I have some examples later on. The Dimenex platform. Dimenex partner has built a platform. What we did, we uploaded almost all our parts, which are stock items, 85,000 parts we have uploaded. And I think we have the same problem as Deutsche Bahn. There's not always enough information with that, but we try to manage this and add information to it so that we can select based on the parameters which are available, selecting parts. In the beginning, we started as well with use cases from the floor, but we are now start moving to a more data approach. It's also because of what we have overcome is that the COVID. Everybody has to stay at home. We cannot do workshops anymore on the workshops. So the focus this year is really on data approach. So we are really selecting parts, digitalize it first, and then from there selecting again parts which we can produce samples for. You see on the right side, you see a pie, maybe a little bit small. There's one part now. What you can see is out of scope parts which can not be printed, like fasteners, stuff like that. And others say the A category is okay. We have printed it in the past because the platform of Dimenex is used from other companies, like in other branches, like for instance Shell, and they have printed already parts which are more or less similar as parts used by NS. So that's how they selected parts. Oh, maybe this is interesting, and then we can look in it in detail. So it's more a funnel to select the correct parts. From the platform, we have now 2,500 parts which could be interested to focus on for 3D printing. And the possibility when you have a tool like this, that you can also look in categories, looking from suppliers. For instance, when we talk with Knorr Bremse, we can select those parts from there and discuss with them, okay, maybe these parts are interesting because they have a long lead item, or long lead items, or have a high MQ, or maybe the price is too high. And the other thing is that we can also capture in this the learning. So when we print an item, we can it's an A category item, and when we select again parts, then we can see that for instance we printed cable holders, and now we printed a few cable holders, and now we're selecting the whole category of cable holders, and we can have printed those parts, start printing those parts. So the whole category will be digitalized and printed. So from case-based studies from the workshops we did. A few examples here. Obsolete items. Now, of course, they come from because we have a problem. But the other parts really have to extract from the workshops. But now we want to extract them from a data approach. So what we noticed with the parts we printed so far is that we have of course the obsolete category. We have the lower batch cost category, or the category where you have high MOQs, or sometimes when you ask only one, you get one, but the price is very high because all the, for instance, tooling costs are offered in one price. So now, you see, for instance, we have an example here. We needed only a few pieces. We could print, but the offer was 50 pieces, and we knew that this item would be running only for a few years. So what we did, we printed this one. So we have no surplus stock for this item. And what I noticed is, looking at this item, it was not used so far. So otherwise we had put 50 pieces on stock, and now we only have 10. And when you do that for a lot of articles, it saves a lot of stock cost, and throwing away stock after the train is out of life. Then lead time, of course, is very interesting, especially because in the rail industry, a lot of parts are the variation, because of you're in the maintenance area, the variation of usage is fluctuating. So I think maybe more than a half, I think maybe 80% of the items are just fluctuating. That's very hard to plan them, put them on stock, the exact amount you need. So, and especially for these items, it's interesting to have a lead time reduction. I told you that we are really looking for partnership with our suppliers. Now, we did that with CAF, as one of our train builders. And we asked them, because so far we printed simple items, like coats, hooks, small parts in plastics. And we asked them, could we print bigger items? Because that's also interesting. So they printed some big items for us. These were samples. I think we printed 10 different items, and we selected one part, and it was a table. And in this table, we are now engineering to an end product. But what you can see, they printed this sample, which already flame retardant. That's a technology CAF uses, is printing a very small, just the geometry, and then put with traditional, I think it's something like polyester. I'm not a technical guy, but put some polyester behind it. So the form is printed and with a kind of hybride technology. And this is flame retardant, so also used items can be printed. Yeah. With another partner, Alstom, we selected also 10 parts as a pilot, and I find this one very interesting because this benefits different areas, not only the supply chain area. What we did, this item was first assembled. There were 6 parts as stock keeping units, and when one disc was broken, one disc was coming from our stock and put in this controller. And what we said, okay, can we print it in one piece? We only put that on stock. I think we have 40,000 euros for this item on stock, and it's almost never used. So we printed as an ID, just printed in one piece. And I think this is a good example because you lower the SKUs, the lead time is reduced, and it is also a better product because it's not assembly; it is one piece. So it is when you have several discs, it can be changed, and this is in one piece, so it's better. The challenge in this is because you want to have these items because I think because they are have a high impact, but you cannot select them from data. That's very difficult. So that's the challenge: how we can find these items. And I think we have to do that more in workshops and show these ideas. Last, because my time is up, is that Carslab, it's the company we use. It's already a partner for a long time. We selected some items, some were obsolete, and some items where we have to wait for more than a year. We asked them to model them and create so-called scent prints. So it's 3D printed scent molds, which you only can use once, and there you can use normal casting techniques to have them available. And what's for instance, I think the right side item, which was obsolete, and we needed 40 pieces, and we did it with this technology. And if you are going to print this, it's too expensive to print this. So, and besides that, you don't have to do all the tests because you stay with the same technology, and it's casting technology. Okay, this was where we are now, focusing more on data and selecting in this way parts for the future. Thank you very much.
Thank you. Thanks so much, Joris. I think very insightful. Well, interesting to see that you've built a real nice network of partners from service providers and material suppliers and so on, and everybody coming together. And it's amazing to see that you have printed more than 150 parts that actually can go into use. So that's it's an excellent collaborating network of partners in your AM advancement that you put together. Very inspiring for us, and thank you for that insightful presentation, Joris. And so far we've heard from 2 large railway companies in Europe. Now let's hear from a supplier's point of view, their perspective. And to take us through that is Bernhard Winkler. He's educated in industrial engineering and holds an EMBA from Technical University of Munich, TUM. In his current position at Knorr Bremse, the world's leading supplier for systems for railway vehicles, he's responsible for the introduction of additive manufacturing technologies as well as digital manufacturing technologies to the workflow. Here to take us into this journey, what they've been doing is Bernhard Winkler. Bernhard.
Thank you, Mahendra, for the kind introduction. And it's an honor for me to present you or to guide you now a little bit through our perspective on additive manufacturing, and especially on additively manufactured spare parts in the railway industry from the perspective of a supplier there. So as you've now heard from the colleagues of the railway operators, Deutsche Bahn and Dutch Railway, whom we also collaborate with, I would like to give you some insights on how we deal from the supplier perspective with this topic. So good morning from Germany, or good afternoon Singapore. On our first slide that I would like to guide you through, I collected a little bit now on this overview, the next slide, the general approach, how we structured our journey. And where we started from is really looking into additive manufacturing as an application for production. So that's what you can see in the left bottom corner. That's where we started from. And then we moved on with applications towards the area of prototyping, with the main attempt in order to reduce lead times, especially for customer projects and R&D projects, which was also already a little bit more sophisticated than just applying additive manufacturing for production in terms of increased productivity, etc. our main focus, whereas at the moment is in those areas where you can see the red 3 and number 4 there. And that's exactly what the colleagues from the railway operators also just mentioned. So mainly the intention there is really to supply products and supply spare parts for obsolete parts. We see two different ways, exactly as Dutch Railway, for example, just presented, either by printing supplier tooling through additive manufacturing, or on the other extent, also directly printing these low demand spare parts. Also, they are always with the scope to deal for the customer with reduced lead time or reduced costs. And the critical point there, I think that's one main message I would like to bring across for all the listeners there, is really the crucial thing is always to identify the right part. So where it either is, or where it makes technically sense, where it's technically feasible, and where it also makes economically sense. So where you have benefits to offer to the customer, like a reduced lead time, like reduced total cost of ownership because you have reduced stock, etc. So this is really a crucial learning that we had to take on that journey. And another really interesting area that we now start to deal with is this upper right area of advanced design products, where I would also like to give you an overview or some insights later on, where we are now, where we now printed also the first parts and applied that into the field of with bionic structures and lightweight structures. So that's a really fancy application there of additive manufacturing, and that could help a lot. On our next slide, you can see a short overview on how we do that within Knorr Bremse company worldwide. So we structured and we combined our competencies in one facility, which is our world's biggest production site in Budapest, in Hungary. We have our own metal printing machine then there. We build up additional capacities to develop the know-how of our employees there. And also we run several plastic printers there. In addition to that, we also have plastic printers in the US and plastic printers, especially in our headquarter and R&D headquarter in Munich. And also in our on one of our Chinese plants in Suzhou, we also have plastic printers meanwhile, to facilitate more efficient production processes and reduced lead times also there. On our next slide, the general approach can be seen a little bit more into detail. And also some sharing there from my perspective would really be, of course, one thing is to set up in-house capacities from the perspective of a supplier to gain experience with the technology and with the different materials yourself. So therefore, we have in-house metal printers and in-house plastic printers, where we are currently in the validation phase of the selected materials, which is very crucial on that journey. But another thing that we are highly putting high effort in, and that I would like to bring across also for the listeners, which was for us a crucial element on that journey and on the approach to apply additive manufacturing in a more broader perspective, are broad collaborations. So either, or first of all, within the railway industry, for example, within the network of Mobility Goes Additive, and there with Deutsche Bahn, or with the discussions with Dutch Railway, but also other operators and other suppliers there, where we are, for example, engaged in exchanging experience and jointly developing standards there, especially when it comes to approval of the parts. And another fundamental pillar of our strategy there is collaboration with suppliers of AM technology. I always make the joke that almost every day someone calls me and say, hey, I reinvented additive manufacturing. I have a new technology. Do you want to buy my machine? If we would buy all the machines, first of all, the company, Knorr Bremse, would almost go bankrupt. And we would have a facility of, I don't know, more than 70 different printers standing around with all different areas of application. So obviously that does not make that much sense. Therefore, we highly stress the collaborations there. We selected dedicated technologies for our in-house capacities and in-house printers. And the rest we try to utilize externally as much as possible through suppliers where we think they are either quicker or much better and faster and more cost efficient in developing those technologies than we could be. So that is, I think that's the four main pillars of our strategy: setting on in-house printers, developing the capacities and the know-how there, but besides that also bet on collaborations within the industry and within technology suppliers there. I would like to give you on our next slide some insights or some short photos just to give you an overview of selected parts that we did. All those are printed on our own machine in Budapest since 2018. We started for the metal printing there on prototypes, parts for case studies, for example, also parts that we put on exhibitions, etc. But meanwhile, also we have now the first part successfully shipped to customers, which is kind of a breakthrough there, because you always need to keep in mind, for us as a supplier, we are dealing with safety relevant products. And as far as I'm informed, for example, also the metro in Singapore relies on Knorr Bremse systems. And I think that everyone who is using that metro, or everyone who is also using a high-speed train anywhere around the world, or a freight train to ship your goods, you always wish that the train stops at the very moment where it is supposed to stop. And that's the core of our business. So we need to ensure that whatever product we bring into the field works exactly as it was engineered for. And for this new manufacturing technology, we need to ensure exactly that. So we have we have to set high standards before we bring any products into the field. So we started intensively with printing prototypes and case studies to gather first experience. On this following slide, you can see one example more in depth. That's a so-called suspension clip. So that's a fundamental part of the brake system. Basically, it ensures that the brake caliper stays where it's supposed to be and adds the force to the brake or brings the force of the brake system to the brake disc. So it really to ensure that the train can stop in the right way. We started off with printing exactly the part in the way as it was designed before. And later on, then we also went to further applications of doing the same one with lightweight structures. That was also in a slightly different layout or design of the product. Actually, the first part that together with the whole network of Mobility Goes Additive and a lot of other partners, that is now the first safety relevant but still approved part that is also operated or running by German railway operators in Hamburg, so north of Germany, in daily operations also with a lot of passengers, like a metro application. And further on, if we skip for one more slide, then you can see another more high sophisticated product, and that's an essential part of a brake system. It looks like a knot. It looks rather complicated, but if we turn the page for one more, you can see one more slide, then you can see more insight. So the upper part shows really the old layout of this whole system, which was basically a pure plate. And in that plate, we had to drill a lot of channels and holes to guide the air for the pneumatic brake system exactly to the point where it is needed for. And then we changed the page and did it or engineered it. No, please leave the slide, sorry. We just did the engineering from the other perspective and said, okay, which functions do we really need and how can we optimize the design for that? Which at the end lead to a complete different layout of the product, still the same functionality, still maintaining all the same safety factors, but reducing weight, for example, by more than 50%, and also reducing the envelope, the space envelope where the part needs to fit in, by also nearly 50%. So that is what we call advanced design of additive manufacturing. Of course, that's kind of where the magic happens, or where there's also huge potential, where we see potential in the market. Nevertheless, for the moment, I think we all in the industry need to focus first of all on gaining more and more experience and bringing products, especially in the spare part or low demand area, into the market. And an essential way how we want to deal with those essential questions that are currently on the table and that need to deal with, I will show you on this next slide with the short circuit there. So at the moment, our main focus is really to gather experience and to gather data as much as possible for our own printing processes. That's where we put high effort in at the moment. And that's also what we learned is essential to enter into a structured validation process. So you need a lot of data, you need statistical data over quite a long time in order to ensure then, and also to prove to the authorities later on that you really know what you do and that all your printed products still keep the same safety factors. So currently we are working on gathering experience and data, then printing parts, testing them, evaluate them, again, gather data, adjust the process, etc. Still always with the aim to develop standards for this process validation or for the approval process, because for the moment, the main challenge there is always that there is no approval or no validation process yet in place in railway industry. So it means that at the moment, for each and every printed part, you need to discuss with the customer again an own validation process, which is of course high effort, and that's all the partners together in the industry want to develop standards commonly together. Furthermore, also one challenge that we deal with and that we are currently discussing with our customers is that there are no AM-specific customer requirements broadly published. Also, that is usually based on discussions or negotiations. And of course, besides that, as with all the new technologies or all innovative technologies, at the very beginning, there's a lack of internal experience and there's a lack of process robustness. So these are, from our supplier perspective, at the very moment, the four main challenges that we need to deal with in order to bring additive manufacturing really to a broad area of application. I can get some more insights on what we really do in this part or in this validation process on the next slide, just a short glimpse. Some of the statistical data that we need to take with and some of the test specimen that we need to print frequently. I will not go into the technical details on that, but just to give you a short glimpse, that really requires extensive validation and a lot of time and a lot of capacity in there. Nevertheless, as you can see on our next slide, there is also an interesting, or what we frequently do in parallel are, of course, analysis from the economical perspective. And this is a short trial run or study that we did a couple of years ago. Meanwhile, I think it was back in 2017, to give you some insights although there. And what we did is really just taking a new product or a prototype of a new product that was currently developed. And we, first of all, asked suppliers on our rapid manufacturing shop to do it with conventional machining. And besides that, we ordered also 5 prototypes from selective laser melting, so additive manufacturing plus additional conventional machining afterwards in order to get the same functional surfaces. And there it was really interesting to take a deeper dive into the business case there, which showed that this business case or the economic viability is always something that you need to look into carefully. I'm not saying that it's only about the price all the time. There are also additional benefits like reduced lead time, reduced total cost of ownership, because you can only print on demand and then ship it to the customer when he exactly needs that. So no stock keeping, etc. But from the pure printing or cost perspective per part, the discussions usually are getting somehow difficult. So when selecting those right parts or focusing on the selection of the right parts, which I mentioned at the very beginning is critical for the success, please take a careful look into these economical benefits and not only focus on the costs per product. Usually that leads nowhere, but focus also on the additional benefits that can be brought along for the customer there, as for example, Joris just mentioned, along the whole supply chain. So that would be my short overview on our supplier perspective. We try to follow that journey along the 5 use cases that I mentioned on the very first slide there. And for our in-house capacities, we currently deal with these 4 challenges that I just described. And we try to deal with those heavily through intensive external collaboration. That would also be my recommendation for everyone who starts his journey into additive manufacturing. So thanks very much for your attention so far. I'm also looking forward to get more questions or into the discussion later on in our Q&A session. Thanks for joining.
All right. Thank you very much, Joris. Yes, just like Joris said, so you've got a button right there for putting your questions up on the Q&A button. So please feel free to do that. And I think we've also collated some questions earlier on, which we will run through in a short while during the panel discussion. But just before we jump into that, I would like to hear from the man himself who has kind of brought all of these different players and operators into one space, into a very sexy name, Mobility Goes Additive. It is really making a lot of impact. To represent Mobility Goes Additive is Arvid, and Arvid himself has been with the Deutsche Bahn group since 2013, and he has designed various programs and innovation projects in the technology department. Being a member of the corporate project 3D printing at Deutsche Bahn, he took the first steps on the subject of 3D printing in 2015. In this project, he himself helped to set up the international network, Mobility Goes Additive. So that's when it was all born. And in January 2017, he took over the management of finance, sales, and technology within the network. And he is also the contact person for the members on technical and economic issues relating to AM. As an industrial engineer himself, he has a passion for digitization. Arvid is professionally and privately interested in all topics relating to the Internet of Things, big data, and Industry 4.0. And he's also has the deputy managing director role, and he takes care of everything in terms of finance within MGA. I don't want to say it anymore, and here is Mr. Arvid Eirich himself.
Thank you, Mahana, for the kind introduction. So I hope you see now my screen, and welcome to my presentation. I will now try to summarize all the presentations which you hear today from our network members. We at MGA, or Mobility Goes Additive, are the leading international network for additive manufacturing, and we are speaking about industrial additive manufacturing. And I want to talk about more not on the use cases and how to find the right use cases. I want to talk about why is it important to have a network like MGA or NAMIC. Why we are talking about additive manufacturing is because according to a study of the Dutch bank ING DIBA, the forecast for the additive production sector is very good. So every 2 years, the production capacity used in industrial additive manufacturing doubles. And this technology is gaining in importance at the user side and at the supplier side. But most of the challenges which additive manufacturing has are the industries which are regulated by state authorities. For example, the aerospace, defense, automotive, rail, medical, or maritime sector, they all have to deal with state authorities like in the rail sector, the European Rail Agency. And here it is difficult to find use cases and establish additive manufacturing, since in this area you hear that today the importance is attached to process stability and standardization of this new technology. However, we have challenges, but we have also a lot of benefits. You heard it today from Joris that the life cycles of rails are let's say usually the longest in these different regulated industries, and the challenges in these sectors are such as life cycle cost, availability, spare part strategy, and maintenance. You heard it today, and this all challenges can be dealt very well and met very well with additive manufacturing. But the problem in that is that every user of this technology who wants to implement additive manufacturing at his company has to deal with different deep approval procedures. And most of the users are faced with these problems and trying in the beginning to solve these problems for themselves. But we on our side are thinking that the first step to success is a different one, not everybody for us alone. We are thinking that the first step is to bundle and build up a network. Build up a network for your company, like Joris and Deutsche Bahn made it, and also Knorr Bremse, but also to have an exchange in the industry and have a network where you can establish contacts and where you can exchange about the use cases which you have seen today, about the know-how, and to set together standards to tell the additive manufacturing industry what is needed as a railway industry, for example, and develop together certifications. So all in all, just to bundle the interests and be one network. We started with this in 2016 and was founded by the European railroad sector, NGA, or Mobility Goes Additive. But after 4 years, we are now exchanging the ideas also with different sectors. So be it the automotive industry, be it aerospace industry, defense industry, everybody is working together because we think you can gain more knowledge if you are sharing your experience. And we have also we are also looking on the sector of the medical sector because we think the topic of approval is, let's say, on the high level the same as in the mobility sector. So our members thought and have decided to accelerate this development of additive manufacturing in different working groups. I don't will tell about every working group. I just want to focus on our working group Railability because they are our, let's say, best in class and blueprint how an exchange as an industry is working. And the railway industry, which you hear today, which have similar demands, are also similar ways to handle the things. We recognize it today. And in our working group Railability, the European railway operators have bundled their interests, and they are sharing the same goals in business life, like availability of spare parts, the extension of the mean time to failure cycles, or the shorten the mean time to repair cycles. So like Joris said, to optimize the supply chain in their companies. So additive manufacturing is a good way to deal with this, and so the European railway providers decided not only to have the same goals in their own business life, they also decided to have the same goals in AM. So they founded in spring 2019 this working group and had themselves the goals for additive manufacturing to work and together and develop a joint database for 3D printed parts where we can exchange the ideas and what they have done. So you don't have to make double work. Everybody has to maybe qualify the same parts so they can bundle their interests. Also exchange experience and values for the identification of components, and also share requirements for development of a new part, and to test together new materials, new technologies, to do research together, and to share the outcomes of research in the market so that they can jointly accelerate the additive manufacturing market as one voice, as we are the railway industry, and we want to accelerate additive manufacturing on this way or on that way. So I think the most important thing what we today hear, or what we hear today, is that additive manufacturing is not a technological or economic problem. You hear it today, but you're seeing that there are also solutions. I think the aspect of a willingness to change in a company and in a sector is the biggest problem which additive manufacturing in the moment has. So additive manufacturing has shown us what it can and what it cannot. We know where we have to, or what we have to improve in this technology, and I think there will be improvements. But in the most implementations of additive manufacturing, the topic of change management is a challenge in the company, and therefore we have collected all the stories of different suppliers and users, like Knorr Bremse today, like Deutsche Bahn, also from the aerospace industry, and brought it all into a book. I think, Mahendran, you got this book from me, so feel free to share it in Singapore. And yeah, let's boost AM together. And I think the best way to start is as a summary, You have a very good network in Singapore. We have a good network here in Europe. We are cooperating with you. Let's bundle everybody here, all our interests, and develop additive manufacturing, and let's boost AM together. Thank you.
Absolutely. I think, Arvid, thank you so much for that introduction to MGA, to all of our Singapore friends here who are getting to know what this whole movement is all about that you guys have started. And there's some questions also rolling in. So what I'd like to do is to invite all the panelists and the speakers back into the stage, as we call it, as well as my colleagues from NAMIC, potentially Dr. Ho, if he also, and Mark Lee, who is the sector lead for land transport at NAMIC, to take on some questions as they come in. So I think since you're on the last speaker, Arvid, and thanks, we are looking forward to the collaboration as well. And this is also one step that we are doing this webinar for our sector and everyone here to really to understand how you have actually grown this to this level and get so many partners involved, etc. So just to touch on that, so for the German railway industry, I mean, this is to you as well as also the Florens, or your colleague from Deutsche Bahn. How did you guys get the OEMs to be involved and supportive of what you are trying to, achieve with your mission and your vision in mind for a long-term adoption of 3D printed parts for the sector?
Yeah. So thank you, Mahendra. I think we have to answer those questions together, Florens and I. So I will look from my economic side, and Florens is the technical specialist. So I think additive manufacturing has shown that it has the potential to overcome the hurdles which we have in this technology over 150 years, but we can now overcome the hurdles like availability, like we offer a service for our customers as a railway industry to bring them from point A to point B. And they don't want to deal with, is there a 3D printed part or is there something else? Is it made out of wood or out of steel? They don't interested in that. They just want to get from point A to point B, and the thing is they want to get it in time and not sometime. And I think the best way is that additive manufacturing can overcome the hurdles because we can shorten the delivery time. And also I think everybody which is also speaking today or in this industry has the same focus. So I think Knorr Bremse is also the same focus, and we want to bring them safe from point A to point B. And so we are all sitting and pushing together at the same challenges. And I think this is what we are combining, what is so unique at the railway industry. So we don't have different companies, we are one sector.
Okay.
Yeah, I think Arvid already explained very good. I think for us it was very to set an example, also to push the OEMs to deal with additive manufacturing. We had good examples in the past that show what is possible, and we have clear needs concerning spare parts availability, and we are frequently talking with our OEMs, with our suppliers, to get AM more and more into business. Of course, it always has to make sense from an economical and technical point of view. But we are working on this in close collaborations with our supply chain.
Okay, thanks, Florens. Okay, so I think there are some questions that are coming in. I'll just pick a couple of them. The first one here is really about what are the challenges and learnings that you have seen in terms of testing and certifications? Because I mean, that is really critical, right, for adoption of these parts. So maybe, across the board, tell us different challenges and learnings that you had in order to get parts actually tested.
Yes, I was, we have, the point is that when you have focusing on the installed base items, or they're becoming obsolete, or you want to change that, that the time to market, the test time is always critical, because, for instance, the business case can be that printing is interesting because you don't have to buy 10 pieces, only one. But the point is that because you change the technology that you have to test it. Sometimes I think that's the challenge, to do that as quick as possible. But it's not always you see that people within the company okay, please hurry up. We cannot wait for the test. We decide to stay with the traditional and buy build a new mold, which is a huge investment. So I think critical in this, the challenge is to shorten the test cycle, and we learning about we really learning on that. And what we are doing right now is starting already digitalization. So you don't have to do that scanning. You do it upfront. And when for instance, that item is becoming obsolete, you only have to plan the testing. Otherwise, you first have to digitalize it, then testing, and then takes too much time. And what the other approach is, that we have to move from the obsolescence and the installed base to new products. So we have to move on and already discuss, for instance, when we buy a new system or change something in the train, that we think about, okay, let's start directly with additive manufacturing and test, for instance, additive manufacturing and the traditional together. And that's the approach, the moving, because otherwise you know that in a certain time it's becoming obsolete. And if you have to test it again, you pay there the testing, and you have already done in the beginning.
Exactly.
So I think we have to move an industry to the beginning and designing directly on additive manufacturing.
Right.
Maybe even the starting costs are even higher, but the total life cycle cost will be lower. And I think that's the challenge here.
Yeah.
I don't know if somebody agrees with that, or Bernhard?
Yeah, I don't know.
Of course, of course.
Of course, I agree with everything that has been said, and I also think that the total cost of ownership throughout the whole life cycle might decrease. For us, to be honest, the challenge at the very moment, or there are two challenges basically, especially when it comes to metal printing of safety critical products. For the moment, there is no defined standard, so you kind of need to develop that validation or testing process on your own, and at the very moment, basically for each and every part or for each and every use case. Once again, of course, you can transfer learnings from one process to another, but you kind of start thinking from scratch every time. So there is no standard, no industry across the industry, no wide standard there. And secondly, it's the sheer amount of influencing factors. So I don't know if any one of you is aware of that famous Ishikawa diagram, where you see that more than 150 parameters influence the outcomes of a metal printing process. And then really finding out which of those 150 parameters is the one that influences the specific properties of your part, or that influences why that printed part, for example, did not meet the expectations or the requirements. That requires, first of all, a solid technical understanding and high amount of time and high amount of statistical data. So these are, from my perspective or from our supplier perspective, the two main challenges: no defined approval or testing process and standard yet, and the sheer amount of influencing parameters that you need to validate.
Yeah, so that clearly shows that there is an opportunity to actually work towards getting some standards that will be adopted industry-wide, right? Yeah. I've got a question here from the audience. For a steel printed parts, now that we're talking about metal, so this is really a relevant question. Are their strength and durability comparable to similar parts made from conventional manufacturing processes?
Yes. So simply said, yes, you can get there. It's not a given. You need to get the parameters right, but then you can definitely reach the same mechanical properties or the same strength, etc., as for conventional parts.
Yeah. I agree with you. I mean, and you also mentioned in your presentation earlier about the two parts with the conventionally produced and 3D printed. almost double the price. I mean, the one that printed on SLM was almost €1,000 and conventional was 2,000. But again, it all kind of comes together at the end of the day in terms of testing and certification for those parts to be even used, isn't it?
Yeah.
Florens, I've got a question here for you. So basically, I mean, is this across the panel as well? I mean, trains, are a public vehicle for transport, etc. So public safety becomes an issue. So when we are dealing with also parts and 3D printed parts that go into it. So how did both the Dutch Railway and Deutsche Bahn approach this evaluation of parts and reliability? And how did you work with any local authorities in Germany and in Holland for acceptance and approval?
Yeah, you mentioned, as you mentioned, it's the key issue to ensure reliability of the part, good quality, because in some cases you talk about safety critical component, and it gets back also to the certification testing topic. For us, it was very important from the beginning to work with qualified suppliers. That's why we also developed, together with other partners like Siemens, like Deutsche, an aerospace company, a certification program for industrial additive manufacturing sites. So you have to make sure that the base quality of the part, that the production process is stable, and when you produce parts, that they meet the requirement. And with this given, you have the chance to qualify parts to get an approval. That's what we're doing. We are working closely together in Mobility Goes Additive in the working group approval with partners like Knorr, Bremse, with other railway companies, testing companies. We had some good examples where we went to a local approval authority last year and got approval. So you have to get some reference, or you have to develop some reference cases. This year we are addressing we're planning to address the General Safety Board in Germany with another or with a similar component. So you have to take step by step. But just to give you an impression, of course, you have to do these highly sophisticated parts, but that's not normal business. So for most of our parts, we are talking about maintenance measures. So we are replacing a component, an existing component, by a component that has the same function, that meets the requirements. So basically, we are replacing one by one. Of course, it's manufactured by another manufacturing technique, but that's how we're doing, and that is how we're doing it, and we don't need to address the National Safety Board for every part. So if we would have to do this, it would take us too much time, and it would ruin most of the business cases, of course. So, yeah.
So a lot of it is pretty much in-house. You're controlling it with working with the OEMs as well, so that these parts are.
Yeah. We need for every part, that is totally clear, we need to get an approval from the vehicle operator. I mean, that's an approval within the company, within our company, but that doesn't have to say that it's easier, because these guys on the side of the vehicle operator, they are very looking on security, on meeting the requirements. We have to get an approval, whether it's from an internal authority or whether it's from an external authority.
I've got a long question here. Firstly, it's from one of the attendees, Jason 10. He's writing, "Hello, thanks for your insightful presentations. Can I ask your opinions on one, with potential increased use of AM and Industry 4.0 in future rolling stock? Will there be a business case for more of the part production facilities to be located nearer to usage locations?" I think this is also in reference to Bernhard, your presentation, such as cities for metro rolling stock. Example in Singapore, will it be still better off placed in locations where production costs are generally lower, which may be in another country, for example, China? And does this apply to the entire automotive industry as well?
So let me ask maybe two split. Of course, manufacturing costs are still an essential factor of additive manufacturing as well, and they are at the very moment. Just if you compare the pure manufacturing costs, they are too high compared to conventional manufacturing. They are getting lower and lower, but they do not depend that much on labor costs as, for example, on conventional manufacturing. Therefore, an advantage of then printing purely in low-cost countries or best-cost countries, the advantage is not that high. From our perspective, additive manufacturing relies more on the know-how and on the capacity of basically the know-how, the process know-how of the people involved. And that basically, of course, then that can happen everywhere. That can happen in Asia, in Singapore, in China, in Germany, or as we do it for the moment in Hungary due to certain reasons. So developing that know-how, I think, is the more crucial factor in there. And then the pure manufacturing costs rely more on other things like the depreciation that you have on the printer, the material costs, the energy costs, etc. Of course, there is still a portion, because for every, especially metal printed part, once again, usually at the end you also need conventional machining in order to get the surfaces right, etc. But compared to conventional manufacturing, these costs are really, really low, or the time for that is reduced by I think more than 50%, almost up to 90%. So the benefit of moving additive manufacturing to low-cost to best-cost countries is not that essential. It's more about the know-how.
Yeah, I mean, just touching on that. So how do you actually decide which parts really to be AM fabricated? I mean, do you really look at the business case for it, or how do you actually determine this?
Usually we try to consider those both factors that I mentioned. So the pure technical feasibility, first of all. Do we have the material for that? Do we have the build space in the printer for the corresponding part? Do we have the right process on hand, either in-house or at suppliers? The technical feasibility is one portion there. And then let's say the economical benefits around, like, do we have an advantage on reduced lead time towards the customer, or in some certain circumstances, can we also get the part cheaper by additive manufacturing compared to conventional process, because we don't have a minimum volume or such benefits. So we always try to balance those two factors.
Okay. I've got a question here from the audience. How is the area of IP rights and IT security while sending out infos to AM manufacturers being handled when you actually send out files? And also, is there any kind of IP protection that you're looking at?
I think the best one is Florens to answer this question, because he had lost a lot of hairs about this question.
Okay. Sure.
Yeah, surely I can answer on that. Contractual agreements, service providers, within the contracts, what suppliers allowed to use data, everybody is allowed to use data. Of course, we are taking some methods when we transfer technical drawings or data, but for us, this issue is not so critical, because we're not talking about, for example, new prototypes from the automotive industry that nobody sees. So we're talking about 30-year-old spare parts, and if someone gets a file, okay, but it's not so critical for us. We are, of course, we're also thinking ahead, so how we want to do this in the future. There are some solutions on the software side in the market. If you think of, for example, Leolane or Identified 3D, there are some solutions, but for us, IP or IT security is not the main pain point. Of course, when you're talking about information from OEMs, IP rights are a relevant issue. So from the beginning, when you evaluate a use case, you have to be very clear that you are allowed to use the technical data or the information you want to use to reproduce this part. So that's what we do at the beginning. We evaluate every part from the legal point of view. If we need assistance, we do that together with our legal department. And of course, there's not one option. If you have an issue and if the OEM is willing to collaborate, that's what we are doing. So we are not focusing on printing all the parts ourselves. We want to also get our suppliers to deliver 3D printed solutions to us. So we are completely open to collaboration.
Thanks, Florens, for that. I've got a question here for Joris. Really when you are designing, for obsolescence, etc. So how often is your design improvement for an obsolete part considered, or is the approach usually a direct copy of the existing part? Do you use design for AM to optimize the parts? Is that something that you guys consider?
Yeah, I mentioned in my presentation already the first example, because you have to change from material to 3D printed material, and normally the material you use is already flame retardant or it's already approved a long time ago, and that's why with the weight, you have to change sometimes the weight, the structure to lower the weight. And most of the parts we printed, which is with a standard PA material, is not flame retardant, but that's because it's under the 100 grams. So that's I think the most cases where we optimize the weight to do that. The rest, should be in try to functional, and some when we have the possibility. I think that the metal parts, what I explained, we didn't print a lot of metal parts. We used sand molds to reproduce them. So in metal, there's only one part I can remember. There was a very small metal part. It was optimized for printing. So I don't have a picture with that, so it's hard to explain. Yeah. But that is only the example. So we little bit stay. Our experience with metal printing is not that much. So metal is usually sand mold used, casting, and focus is mainly on plastics. Mm-hmm. Yeah. Okay. And then we redesign for the volume. Maybe I come back to the question which Bernhard was explaining. Because another benefit, I think a big benefit, is where in the situation we are right now, that especially in March when there was a lot of lockdowns in Europe and Asia, that you want to have availability, that your supply chain becomes more resilient. And that's that you can switch easily from one production to an area. I think the next step is that when you, for instance, when Bernhard can print the part in his own factory, that he can also print it somewhere else nearby our factory. When, for instance, the supply chain is disrupting or the capacity is there's no capacity in their own facility. I think that's also a next step, and also a huge benefit of 3D printing, because you don't need tools, you only need the machines.
Yep. No, you're right. You're absolutely right on that. We have a question on, in terms of to evaluate for the right part and for AM exploration. Can the speakers share more about their evaluation rubric and your experience?
As you saw before, we have key criteria.
Florens, you're breaking up a bit. Can't quite catch you there. Yeah.
Maybe I can answer Florens.
Yeah, maybe Arvid, you can take that question. Thanks.
Yeah. So to find the right part, we have tried two ways, and we have seen that the approach is the other way at the railway industry. So there are, let's say, two ways: the top-down way and the bottom-up way. So the top-down way was just like Joris said. We collected all the data which we had about every spare part at Deutsche Bahn heavy maintenance, and tried to evaluate it with a tool to, let's say, to push all this data in one tool and to find out, okay, what is the right application? If it depends on size, if it depends on costs, on delivery time, etc. And let's say it was a lot of work, I think 3 or 4 months of Florens and his team's time. And I don't think that it was such a successful way. Yeah. And then Florens changed the way and said, okay, top-down doesn't work very good because Deutsche Bahn is only a provider or an operator. All the data which we need for such a successful process is the data which Bernhard has. So Bernhard maybe can say what a supplier view is, how this top-down process works. But we have seen, okay, we need a bottom-up process like this employee competition, but we want to ask the people who are dealing every day with spare parts and with our trains, like our workers in the workshops, okay, which parts are the parts where you are really angry about it, that is, the delivery time is bad, that you don't get it, and so on. And this is how we are approaching it bottom up. So we made a roadshow through all our workshops, shown to them what can additive manufacturing do and what can additive manufacturing not do. What are we searching for? And then to convince them by successfully have a solution for the challenges within a quick time. And then more and more parts came up. So we have now more than 20,000 parts. But this is our view of the Deutsche Bahn. I think Joris made it a different way and Bernhard also.
Maybe to add something, our experience was in the beginning as well that it was hard to use data to select the parts, but with the help of Dymanex and their knowledge from that system, we have now, for instance, what we do, we focus really on supply chain, and there as well with the semantic search tool Dymanex have, we can select create a funnel where we can have, I show you 2,500 parts which are interesting. And what I also can do, I can also select a list from Knorr and discuss it with Bernhard. I think we had a year ago or 1.5 years ago, we discussed the same thing. And I find it very hard to have the right parts to be discussed with Knorr, because Knorr is asking us, okay, where do you need help? Which parts? And I think we are now in a better situation to list those parts and have the discussion. Bernhard, please help us. We see here enormous lead time, and we still have to use these parts for the coming 20 years. Okay, I think it's interesting to invest together to look if you can change this part in digitalization, step 1, and then look if you can additive manufacture it.
Yeah. Thanks, Joris. Hyung-hya, I think that answers your question. We have another question here. Is there an estimate number on the spare parts that are now being made with AM against the total number of spare parts that are needed? Do you have any projections on the growth of this ratio?
Maybe I can answer that from Knorr Bremse perspective. Still, I don't have the latest figures. We did such kind of analysis at the beginning of our journey into additive manufacturing in order to also kind of show to the management that what we do really will have an impact on the company. There we started with I would also call it more top-down approach where we looked together with our colleagues from the sales departments in our spare parts business into those customer demands or into those cases where they had a real customer demand that they could not fulfill at that moment in time because, for example, there was a minimum order quantity from the supplier that did not fit to the expectations. The lead time was too long, the molds were not longer available, etc. And out of that, we then just analyzed from a pure technical perspective, how many of those parts could we technically provide with additive manufacturing because the material is available, the build size would fit, etc. And no look into any economical factors. So just out of this technical feasibility study, we came to the conclusion at that point in time, which was end of 2016, beginning 2017, I think, that 10% of those parts that could not be supplied by conventional technologies, 10% would directly fit into additive manufacturing. I would assume that meanwhile, this amount has increased a lot because there are many new technologies are available with new materials, bigger build size, etc. So I would say that this increased a lot. Still, it's hard to say compared to the overall volume of spare parts that we sell into the railway industry. I think there was also a study once published or done by Siemens where they gave a number that they said approximately they aim at providing 5% of their total spare part business through additive manufacturing. I think that's still a reasonable number. So the 5% would be a way to go for.
Okay, thanks, Bernhard. I know we are running over quite a bit and our speakers have got a very busy schedule as well today. So I'm going to just jump into one of the last questions here. Do we foresee that there is a demand on bigger scale for 3D printer machines since some of the parts identified constrained by the printer size and you want to print big? Anyone wants to take that? Arvid?
I think for some parts, can you hear me now better?
Yes, we can.
I think for some parts there surely is, but at the moment I would say that's not the main driver. So for further industrialization of AM, production process needs to be more cost effective, more efficient, and we need to lower the cost for quality inspection. I think that is way more important than printing larger parts because that takes a huge part in the business case. This whole qualification testing. We need to get better in this area.
Yeah. Okay. Thank you, Florens. I think so. We've answered quite a lot of questions. There's still a few unanswered questions which we will take, and we'll take it offline, and we will reach out to participants who have stayed with us over the last couple of hours, listening to wonderful speakers here. So thank you so much, and I would like to also thank our speakers for taking the trouble to join us and tell us all about whatever they have experienced and through their knowledge that they have gained in the last years, how AM can really help to bring this forward. So, a heartfelt thanks from NAMIC to the speakers from MGA, Arvid, to Joris, to Florens, as well as I keep getting your name. Always
Bernhard.
Okay, Bernhard, Winkler. Yeah, Bernhard. Okay, thank you so much. And so we will still be in touch. And for all the attendees, kindly contact us if you have more questions and you want to engage with them. We will make the necessary connection, and that's really the outcome that we are looking for a lot more collaboration. And Bernhard, for sure, we want to see your presence in Singapore as well, not only in the other parts in Asia, but Singapore is the place to be. And thank you so much. Till we meet again, this is Mahendran Reddy on behalf of Team NAMIC signing off. Thank you very much, folks. See you again soon.
Thank you. Goodbye.
Bye.
Thank you. Bye-bye.